Students, welcome to this video. In this video, we will see the topic electrochemistry, session 6. Before watching this video, you subscribe this channel and press the bell button. Okay, thank you. Now, the objectives, learning objectives in this session. Number 1, measurement of the electrode potential. Next, thermodynamics of cell reactions, and then Nernst equation. These are the main topics in this session. Okay, now one by one we will see that. First, measurement of electrode potential. Now, in the cell there are two electrodes, positive electrodes, that is anode, and another one is cathode electrodes are there. We know that. In each of cells, the reactions occurs oxidation and reduction. The whole reactions is called redox reaction. So the redox reaction, two of reactions, reduction and oxidation. Okay. Now the EM of the cell also we know, we want to calculate for the calculations, because EMF is important in each electrodes. That is, the sum of electrode potentials at the cathode and anode are the total EMF of the cell. So each electrodes, the EMF is important for us. The equation is E cell is equal to E oxidation anode and E reduction cathode. This is the equation. Now the oxidation anode represents the oxidation potential, and reduction in cathode represents the reduction potential of the cathode. It is impossible for the calculation of EMF in single electrode, because the difference potentials is created between the two electrodes. So each electrode we cannot measure the EMF. Okay, between the EMF of the cell is calculated using voltmeter. We know that EMF of any one of electrons constitute the cell. The calculate of EMF of the other electrode from the measured EMF of the cell using the above expression. If we want any one of the electrodes EMF, one is fixed with the standard electrode to calculate experimentally. Okay, if we want any one, oxidation anode or reduction cathode, if we want one is the reference cell, with the reference cell. So that is standardization. Okay. Now the reference electrode is known as standard hydrogen electrode, that is called SHE. In electrochemistry, very important standard electrode for experiment is C cell, SHE, standard hydrogen electrode. We see the this is the name of the C. The image is here displayed. This is the standard hydrogen electrode diagram. See that the test tube immersed in the solution. In this test tube, the platinum electrodes are fixed inside this, and then one open tube is there, open way, hydrogen gas in atmospheric pressure. Hydrogen gas entered into the this inside cell. Inside the platinum wire is there. Next, in downwards, the platinum electrodes also fixed. Platinum electrodes, platinum wire, and then platinum electrode. Okay. Next, hydrogen gas is outlet. Therefore, here inside the beaker, 1 mole of H plus aqueous solution, H plus means acid solution is there, acid solution is there. This is the basic construction of the cell. Okay. Now in platinum electrode, the platinum ions are bonding with each other in platinum metal. Okay. The hydrogen gas are deposited on this electrode, and then at the time of electrolysis, the hydrogen gases are acquired 1 electron from each, and then changes to hydrogen molecule. The half reactions is 2H plus aqueous plus 2 electron gives H2 gas. 2H plus aqueous solutions are absorbed to this electron and changes to hydrogen molecule. This is the basic principle of this diagram. Okay. Now the standard hydrogen electrode is used as the reference electrode. This is very, very important. What is the reference electrode in electrochemistry? E means C is very, very important. SHE, standard hydrogen electrode. Next, the arbitrary EMF exactly 0 volt. In this electrode, C electrode, the EMF of the electrode is totally 0 volt, totally 0. So this is used for standardization. Okay, it consists of platinum electrode. I already told that the contact with 1 mole of hydrochloric acid, 1 mole of hydrochloric is inside the beaker, and 1 atmospheric pressure of hydrogen gas entered into the test tube. Okay. Now the hydrogen gas is bubbled through the solution 25 degree C as shown in the figure, already explained. Okay. C is act as a cathode as well as anode. C can act as a cathode as well as anode. Both they are. That's why it reference cell. It is used for reference cell. C can act as a cathode as well as anode. The off cell reactions are given below. Here C is used as a cathode. The reduction reaction H reduction is occurs in cathode. Okay. 2H plus means acid, in acid, and acquired 2 electron gives H2, changes to hydrogen molecule. Gas EMF is 0 volt. Anode, if we chance to use anode, the oxidation reaction H2 gas is split into H plus and 2 electron, release 2 electron. This is 0 volt. Okay, anyone we use the standardization for standardization. Okay. Now illustration, the electrode reduction potential of zinc electrode dipped in zinc sulfate solution. How we calculate the electrode potential of zinc electrode and zinc sulfate solution? Step 1, in galvanic cell constructed using C, ZS, this is the metal dipped in anode, and aqueous solution have zinc sulfate Zn2 plus ion. 2 plus ion is using the solution. Next, standardization, hydrogen acid, 1 mole acid, and then hydrogen gas and platinum electrode. So this is the standard, one off is the standard electrode, using standard electrode. Step 2, galvanic cell is measured using voltmeter. In case measure the EMF of the cell is this is the standard value for zinc cell, that is galvanic cell, 0.76 volt. This is the value. Very, very important, 1 mark question. You noted that 0.76 volt for galvanic cell. So calculation, we entered to the calculation. E0 cell is equal to oxidation and reduction. The oxidation means Zn and Sn, this is the one part, Zns and Zn2 plus, 1 off. And then reduction takes place is, this is the C cell. Okay. Now E cell is equal to 0.76 and E cell is 0 volt. This value is already find out that already fixed. So this substitute the value of this electrode, we get the value. the 0.76 volt is equal to Zn, Zn2 plus 0 volt. 0 volt means C voltage, C cell, from C cell. So oxidation is equal to 0.76 volt. This is the plus or minus, you noted that. This is a plus 0.76 voltage. Okay. The oxidation potential corresponds to this takes place at the cathode. Cathode means Zn tends to that is gives Zn2 plus and 2 electron. That Zn2 plus solution accept 2 electrons, changes to zinc metal. Therefore EMF of the cell is equal to 0.76 volt. This is the measurement for this. The construction of one electrode using zinc and zinc sulfate solution as one electrode. Okay. Zinc is anode, zinc nitrate aqueous solution, zinc nitrate. Okay. And then sodium chloride inside the bridge, sodium chloride and agar already know that agar gel with agar gel, sodium chloride. This is the salt bridge. And then nitrate ion is moved to the anode ion, and then Zn2 plus is moved to the cathode ion. That Cl minus and Na plus are across the movement with this is the no reaction salt bridge. Okay. Now the electrode C is there. C cathode, hydrogen gas is inside the electrode, and HNO3 nitric acid is there. So H plus and 2 electron, acquired 2 electron is gives H2. From this 2 electron is movement from the anode, So Zn plus 2H plus gives Zn2 plus and hydrogen. This is the overall reaction of this cell. Okay, this is the illustration. You know that. Okay. Now E0 reduction Zn2 plus Zn. This is reduction is minus 76 volt. But here oxidation is there. Therefore oxidation volt plus in this 2 value is don't remember that. This is oxidation, this is reduction. Okay. This is oxidation potential plus 0.76, reduction potential minus 0.76. Okay. Next, very important topic, thermodynamics of cell reactions. Thermodynamic cell reactions, we already know that galvanic cell, the chemical energy is converted to electrical energy. Underline it, one more question. The chemical energy is converted into electrical energy. The galvanic cell cell's principle, that is chemical energy is converted to electrical energy. Now the electrical energy produced by the cell is equal to the product of the total charge of electrons and EMF of the cell drives these electrons between the electrodes. We already know that the electrons are moved from anode to cathode. Anode example, for example, zinc 2 plus zinc metal loses 2 electron. This 2 electron moves to cathode. They combine with Zn2 plus again deposited as a zinc. This is the example. So the electrical energy is produced. In this movement, the electrical energy is produced by the movement of electron is equal to the product of total charge of electron. This is very important key point. The total charge of electrons and the EMF of the cell drives this electron between electrodes. Okay, electrodes means positive and negative, anode and cathode. Now N is the number of moles electrons exchanged between the oxidizing and reducing agent in overall cell reaction. This is very important because N is small n is the used in as a formula, used in formula. So N is number of moles of electrons. Total number of electrons exchanged between the oxidizing and reducing part, oxidization part and reduction part. Okay, the electrical energy produced by the cell is given below. now the formula, the electrical energy, total electrical energy is equal to charge of electrical n mole of electrons E cell. Okay, the charge of 1 mole of electron is equal to 1 Faraday. 1 Faraday, this is in physics, you know that. What is 1 Faraday? 1 Faraday means that the 1 mole of electrons moved between the electrodes. At that time the charge is 1 Faraday. 1 Faraday. No, n mole of electrons, 1 mole of electrons equal to 1 Faraday, n mole of electrons n Faraday. Understand? Therefore, electrical energy, same equation. So, electrical energy equal to charge n mole of electrons E cell. So, electrical energy equal to n F E cell. N is number of moles movement, the charge charge of the n mole of atoms, n mole of electrons, 1 Faraday, and then E cell. This is the total formula for electrical energy. Okay, understand? Now, in this formula, we make the calculation. The charge of 1 electron is equal to, this is the standard value. Don't forget that. Very important 1 mark question. The charge of electron is equal to 1.602 into 10 to the power of minus 19 coulomb. Coulomb, C means coulomb. The charge of 1 mole of electron, this is 1 electron charge, that is 1 mole of electron equal to 6.023 into 10 to the power of 23. This is the Avogadro number. Avogadro number of molecules, number of atoms in 1 mole, that is 6.023 into 10 to the power of 23 into 1.602 into 10 to the power of minus 19. 1 electron charge. This is Avogadro number. Total value is 96,480 coulomb. The round of it, and 1 Faraday is equal to 96,500 coulomb. This is the very important 2 mark question. How it reaches the value 1 Faraday is equal to 96,500 coulomb. This is the derivation. This is the derivation for this 1 electron and n mole of electron. So, 1 mole of electron. Okay, 1 Faraday is equal to 96,500 coulomb. Now, relationship between EMF and free energy. This is very important 5 mark question in this chapter. Fluently ask the questions in this chapter. Okay. Relationship between the EMF and free energy. This energy is used to electric work. Already you know that in thermodynamics the energy is used for electric work. The maximum work is equal to minus NEF E cell. This is already know that the total electrical energy is the formula NF E cell. Therefore, work maximum is equal to minus, this is the first equation. This minus symbol, what represents this minus symbol means it is introduced to indicate the work is done by the system. This is underline it, this is a word very important, by the system and the surrounding, by the system and this minus plus, no plus value. In this equation minus value is there, this meaning of the minus is the work done by the system and the surrounding. This is the meaning. Okay, very important 1 mark question. NEET also or JEE also, this is a very important 1 mark question. The second law of thermodynamics, work maximum equal to delta G. Delta G means gives free energy of the system in thermodynamics. Work maximum equal to delta G. So, delta G is equal to minus, equate this minus G NF E cell. Okay. Now, explanation. The spontaneous cell reaction, the delta is minus negative value. You already learned in 11th standard. Delta G value is minus means that reaction is spontaneous reaction. So, always negative for spontaneous reaction. Now, E cell should be positive. If delta G value is minus means E cell value is positive. to get negative delta G value. This is a very, very important point in this derivation. Cell components delta 0, that is standard state, means delta G0 is equal to E minus N of E0 cell. So, the standard free energy change is related to this equilibrium constant as per the following equation. Now, delta G is equal to, this is the standard formula in 11th standard, minus RT ln K equilibrium. Delta G is equal to minus RT ln K equilibrium. Okay. Now we compared as minus NFE is equal to minus RT ln K equilibrium. So minus minus cancel, this are for plus. Okay. Here also minus. Before that also in this equation this also minus NEFE cell. So minus minus cancel, and the NFE cell is equal to RT log N. So E0 cell is equal to 2.303 RT. Ln is changes to multiplication of 2.303. This is the value for changing Ln to log. So 2.303 RT divided by NF, this NF is bring to denominator. Okay, log K equilibrium. This is the formula, very, very important formula, very, very important 1 mark, very, very important NEET and JEE exam. Next, Nernst equation. Nernst equation is another important 5 mark question in this chapter, fluently asking the question, what explanation or derivation for the Nernst equation. Now, Nernst equation is one of the very, very important relationship for cell potential and the concentration of the species involved electrochemical reaction. Okay, this is the concept. Nernst equation is related between cell potential and concentration of the species. So, in electrochemical reaction, overall redox reaction, XA plus YB equilibrium LC plus MD. A, B means chemical, X means number of moles, X, Y and LM is the number of moles. This is the general equilibrium equation. This is the assumption only. The equation quotient Q is equal to, the equilibrium quotient is equal to, Q is equal to concentration of C power L, that is products, concentration of C L power L, D concentration of D power M divided by reactants A and B, A x power x, B power y. We already know that delta G is equal to delta G0 plus RT log ln Q. Q is this is the quotient. Okay, this substitute this value. The delta G value already know that minus NFE cell before the derivation already note that delta G value is minus FE cell and delta G0 is equal to man FE0 cell. Okay, this is changes to 0. Okay, the substitute the above equation, N minus NFE cell is equal to minus NFE0 cell and RT ln the quotient Q value substitution. Divide this equation, E cell is equal to because in the minus NF division, minus NF means here also NF is there, here also NF is there. So NF divide the NF whole equation NF. Now NF divide the NF means E0 cell minus RT divided by N ln C concentration of C A power L, concentration of D power M divided by concentration of A x B y. this is reactant, this is the this is the product, this is the reactant, concentrations, multiplication of concentration. Okay, or E0 equal to E0 cell, the ln is changes to log by 2.303, multiplication of 2.303 RT divided by NF. Okay, log, this is log, the natural logarithmic, this is the logarithmic. Okay, now this is called the Nernst equation. This is very, very important 2-mark question. What is Nernst equation means? E cell is equal to E0 cell minus 2.303 RT divided by NF ln concentration of products divided by concentration of the reactant. Okay. Now substitute the values for the R and T and Faraday, 1 Faraday. 2.303 into 8.314 into 298 divided by N into 96,500 Coulomb. 1 Faraday is equal to Coulomb. So substitute this value. This is the description for R value is 8.314 joule per Kelvin per mole. This is already know that, memory, you memory it. Now the full expression for the calculation, I manually write the calculation. E cell minus 2.303 8.314 into 298 N into 96.5 into 10 to the power of 2, that is 96,500. I write this type of splitting to this. Now take the log value for calculation. Log 2303 tends to 0.3623 using this in logarithmic table. You have the table in physics book backside. Okay, 8.314 log value is 19198. 298 3 digits means 2 point. 3 digits 1 reduced to 1, 2.4742. Now addition takes place. Addition takes place 3.7563. Therefore 3 terms is there, all are added. Next 965, you 10 to the power of 2 is leave it. Okay, 3 digits means 2.98. Subtract this from this, subtract 0.7722. Take antilog this 5.919. This is the final value for this term. This substitute this value. E cell is equal to E0 cell minus 5.919 divided by N into 10 to the power of 2 log the quotient concept. Okay, E0 cell minus 0.055919 divided by N molecule. You move to this power to numerator minus 2. Minus 2 means 0.05. Okay, understand this concept. So whole value, final answer is E0 cell is equal to E0 cell minus 0.0591 divided by N log C L D power M A power X B power Y. This is the final EMF of the cell is equal to E0 cell minus these values. Okay, understand it. If you can't understand, you comment your doubt in my channel. Okay. Next, the important derivation for Nernst equation. One example is there. I will show that. This is a book back problem, example, book inside problem, Nernst equation inside problem, page number 51. Calculate the EM of the following cell at 25 degree centigrade using Nernst equation. In Nernst equation is the cell notation is given that this is the problem question. Cu solid single slash Cu2 plus inside the bracket the concentration 0.25 mole aqueous solution. Okay, double salt bridge double slash, and then next of means Fe3 plus the concentration of the solution is 0.05 aqueous solution, and then mole. This is the mole concentration 0.005 mole. Then next slash Fe2 plus ion, Fe3 plus ion, again Fe2 plus ion aqueous solution 0.1 aqueous single slash platinum electrode solid. Okay, the two halves here already given that the value of E0 Fe2 plus 3 plus 2 plus ion 0.77 volt, and then copper 2 plus and copper is equal to 0.34 volt. This is given that. From these values you calculate the EMF of the cell. This is the cell notation for this. Before that I explained that, easily understand that, carefully you watch this equation, because very important problem in this question. Okay, now calculate the EMF of the following cell. The cell notation is first of copper solid is changes to copper 2 plus copper solid, and then electrode is copper, and then solution is copper 2 plus. Next half cell is ion 3 plus ion and 2 plus ion, and then platinum electrode. This is the total cell notation for this. Okay, you write the equation balancing. Now first two halves reactions are as per electron releasing, which one is oxidation, which one is reduction. You write it, this is oxidation and this is reduction. Copper solid is changes to copper 2 plus aqueous solution plus 2 electron, releasing 2 electron. Next this 2 electron is accepted by Fe3 plus ion, changes to Fe2 plus ion. This side is one change, this side is one change. This is electron releasing off, and then is accepting off. So total balance in this equation, 2 electrons take out this, and then copper solid and 2 Fe2 plus 3 plus Fe3 plus 2 Fe3 plus gives 2 plus ion, because the 2 electron is absorbed by the copper 2 plus ion, and then Fe2 plus ion, the Fe3 plus changes to Fe2 plus ion, because copper releasing 2 electron, Fe3 plus is accepting 2 electron. So the whole equation is this is. In this equation the solid is omitted, because solid is equal to copper solid is equal to what? Platinum solid is equal to 1 value. Solid is negligible value. Okay, standard value is 1 solid for the solid. Next we calculate the E cell is equal to E0 cell minus this is the formula, minus 0.059 divided by n mole into log copper 2 plus and Fe2 plus. The products, what are the products? Copper 2 plus and Fe2 plus is a concentration divided by reactants. Copper S is omitted, and then copper ion 3 plus concentration. So the electron releasing electron n is equal to 2, so substitute the value n is equal to 2, therefore E0 cell minus 0.0591 divided by 2 concentration of copper 2 plus and Fe2 3 plus divided by Fe2 plus divided by Fe3 plus twice. Okay, next page I will show. Next step, E0, we want E0 cell is equal to the formula E0 oxidation Cu C2 plus plus E0 reduction Fe2 plus Fe3 plus. Okay, this is the formula for this E0 cell. So E0 cell oxidation CuC2 plus equal to minus 0.34 volt. We already know that reduction part of copper 2 plus 2 copper. This is changed. Copper 2 plus equal to minus ion, minus symbol, that is oxidation. Reduction means copper 2 plus 2 changes to copper. So 0.34 plus 0.34 volt. So we want the oxidation part. Oxidation is minus 0.34 volt. So E cell is equal to minus 3.4 volt in plus 0.77. Okay. E0 cell is equal to 0.43. Now the chemical reaction equation and Nernst equation. The equation developed, substitute the E0 value to E cell value, E cell formula. E cell is equal to 0.43 minus 0.0591 divided by 2 log concentrations, fill the concentrations 0.25 into 0.1 whole square divided by 0.005 whole square. Okay, you cancel 2 0.02955. Okay, 0.43 minus 0.02955 into 10 to the log 0.25 into 0.01 divided by 0.1 means 0.1 into whole square, then 0.1. Okay, 0.000 4 times 0 25. Okay, now next step 0.43 minus 0.0295 into log, I rewrite the steps again. 0.25 is rewrite to 25 divided by 100, 0.01 rewrite to 1 by 100 divided by 25, 6 times 0, that is 10 lakh. Okay, now next step 0.43 minus 0.02955 into log 25 into 10 to the power of minus 2 into 10 to the power of minus 2 divided by 25 into minus 6. The denominator is converted to minus 2 in numerator. So 0.43 minus 0.0255 log 10 to the power of minus 4, this is the minus 4 value. This is minus 6 is numerator, bring to the numerator plus 6. So 0.43 minus 0.0295 into log 10 to the power of 2. Again 2 is before write the log because the power is bring to the before log. 0.43 minus 0.02955 into 2 into 1, that is 0.43 minus 0.05910 is equal to 0.3709. Therefore final value E cell is equal to 0.3709 volt. This is the answer. Okay, thank you for watching this video. Again I will tell, please subscribe the videos and press the bell button, because we updated new videos as soon as possible. Okay, thank you.